Hello, everyone. How you doing? This is a review session for the final exam, Algebra 1, for Miss Mezzina's class. I did promise to make you guys a recording of all the questions worked out, especially because I'll be leaving the country, and I didn't want to leave you guys hanging. So please make good use of this. This is by no means an invitation for you to just copy the answers down. It's definitely a resource for you to use correctly. And what does that mean? That means you have to print this packet out, attempt the questions on your own first, and then either come back to check your answers, or two, if you get stuck on a specific problem, then you can come over here and learn how to do the problem. But don't just use this to just look like you would watch a video. Don't do that. You have to literally work out the questions yourself. Okay, so let's hop right in, and feel free to pause or rewind as many times as you need to. And I wish you the best. I'm going to turn off my camera because my computer just works better without my camera being on. So I'm not ignoring you guys. It just works better that way. So let's begin. Okay, so the first question is asking us to write expressions as algebraic expressions, to write words. So like, little sentences like algebraic expressions. So 3 less than 2 times a number. So 3 less than, that tells you you have to have something first. What do you have to have first? 2 times a number. So 2 times some number. But we want 3 less than that, so it'd be 2n minus 3. The next question, the quotient of 3 more than a number and 16. So quotient means division, for those who are wondering. And then we have 2 things that are being divided. What are they? 3 more than a number is that first thing. And the second thing is 16. So it'll be 3 more than a number is n plus 3. 3 more than a number divided by 16. Let's move along. The next question is taking expressions and writing them as verbal expressions. So we are doing the opposite of what we did prior. So here we have this part right here. And of course, we have a subtraction sign, and we have this second piece. So we can say this as 10 less than the quotient of x and 3. So again, x and 3 is its own thing, and then 10's over here. So should probably use words, not use numbers. So change the 3 that I had as a number to actual words, 3. Okay, then the next question, it's again a division question, as you can see the division symbol here. So this will be quotient. Remember, division means quotient. So this is the quotient of 4 more than a number and 2. Again, the 2 parts are 4 more than a number right there, x plus 4, and 2, the second piece. So that would be your answer in words. So question 3, model each situation as an algebraic equation. You do not need to solve the equation. Also, don't forget to state your variables. Hannah is practicing her volleyball serve. She hits 5 balls into the net and the rest inside the court. She served 22 balls in total. So I guess the unknown, okay, so 5 balls went into the net. So that's known. The rest of them fell inside the court. So we don't know how many these are. So let's come up with a variable for this. We'll say x, and we'll define x or state x as x is the number of balls, of serves, I guess we could say. Number of serves, or just balls, number of balls that fell inside the court. So we know if we count the number of balls that fell inside the court plus the number of balls that hit the net, those should add up to the total amount of serves that she had, which was 22. And that's our equation. We do not need to solve it. The second question, Ava is also practicing her volleyball serve. She starts with serving 3 balls as a warm up. Then she serves 2 balls every minute until she's served 30 balls in total. So we know that we are starting out, rather, Ava started out with serving 3 balls. So I guess what's missing here is the total number of balls. We'll say, let's use T for total. T is the total number of balls served. Total number of balls Ava served. You do not have to be as elaborate as I am, so you can use fewer words in the interest of time. But we know that Ava served 3 balls, and then she is serving 2 balls every minute for a grand total of 30 balls. So we should probably change that because we had the total. So we don't even have to define T. So I'm going to change this to M because I guess the unknown here is how many minutes would it take her to serve 30 balls. So let's just change that to M is the number of minutes it would take Ava to serve all 30 balls. Okay, on to the next question, part C. A magazine subscription costs $19.99 up front, so that's a flat fee, and then $9 per month. So we know the cost per month. We know the flat fee that you're paying up front. What we don't know is what the total cost would be for that month, right? So let's just say C will be the cost of the magazine. This is of the magazine subscription. So we can say the cost will be the $19.99 that you have to pay up front plus the $9.50 you're paying per month. So I think it would be wise to also say M because we have 2 unknowns. We don't know the cost, and we also don't know what the cost is going to be. That's actually determined by the number of months. So I'm going to say M would be the number of months. So that's what that equation would be, the answer rather. On to the next one. You're being asked to evaluate this expression right here. So evaluating just means work it out using PEMDAS. So 3 squared is 9 minus, well, let me actually write PEMDAS out so I can maybe remind you what that stands for. Parentheses, exponents, multiplication, division, addition, and then subtraction. As a quick reminder, if a question only has multiplication and division, you go left to right. And if a question only has addition and subtraction, you go left to right. So now let's do the math. 3 squared is 9 minus, we got to do what's inside of those parentheses. 4 minus 7 is a -3. All of this divided by the bottom here is a multiplication. 2 times 3 is a 6 minus 2. And then we can clean this up a little bit more. 9 minus -3. Remember, when you have 2 negatives next to each other like that, they're going to just turn into a plus, right? So that's 9 plus 3. So that ends up being a 12 over 6 minus 2, which is a 4. 12 divided by 4 is 3. So the answer to question 4 is 3. On to the next one. If you have a number outside of parentheses, you want to use the distributive property. It's an invitation to multiply the numbers inside of that parenthesis by the number that's outside. So 4 times 13 is 52. So that's going to be 52x plus 8y minus 36. Done. The next question is inviting you to factor. Factoring requires you to figure out the greatest common factor. In other words, what's the largest number, if there is one, that goes into all the terms? So is there any number that goes into 12 and the 6 and the 24? If you're thinking a 3, you would be correct. No, I'm sorry. If you're thinking a 6, the GCF is 6. 6 goes into all of them. So we take out a 6 and we are left with a 2x to the second minus 1y. I'm just going to say minus y plus 4. That's fully factored. So for the definition questions, I'm actually going to have you guys look those up online, but I'll give you a quick overview. Commutative property, there are two. There's a commutative property of addition, and there's one for subtraction. I'm going to illustrate. So subtraction, so you guys can, when you Google this, you will see, I'll do one for each. So when you're commuting, it means that you're traveling. And really what this says is, if I can take two numbers and add them together, for example, a plus b, if I change that order, the answer should not change. It's going to be the same. As an example, if I have 3 plus 4, my answer should be the same as 4 plus 3. It doesn't matter what I write first. The numbers are commuting. By the way, I misspoke. It's not commutative property is addition and multiplication, not subtraction. I'm so sorry. I read multiplication. Change that. So that's the example for multiplication. For addition. Now here's the example for multiplication. And same rule, really. If I take two numbers and I'm multiplying them together, I'm going to say a times b. I could even do three numbers, a times b times c. And then I change the order of those numbers and maybe say b times c times a. It doesn't matter what order they're in. If they're being multiplied, the answer will be the same. Let's do this. Let's do an example. Let's use numbers. For example, 2 times 3 times 4. If we change that order, and now 2 is last, 4 is in the middle, and 3 is in the beginning, the answer is going to be the same. 2 times 3 times 4 is 24. 3 times 4 times 2 is also 24. That's what commutative property said. You can make your own examples. And now we have another important rule to us known as associative property. This one, you associate things. It's like you're grouping them together using parentheses. So as an example, once again, there are two of these. There's an associative property of addition and an associative property of multiplication. So if I had like an A plus B plus C, and I associate these two together, if I change the grouping of those and maybe say A plus B plus C, but this time I associate these two together, the answer doesn't change. It should be the same answer. For instance, if you have a 3 plus 4 plus 7, then these are grouped together. That should not make a difference than if I have a 3 plus 4 plus 7, and I group these two together. Same answer. That's what associative property does. For multiplication, same idea, except for you're multiplying a times b times c. I could associate those two and have a times b times c. The answer would be the same. It doesn't matter. So if I have 2 times 3 times 5 and I associate these two, it doesn't matter if I associate a different group. I group them differently rather. 2 times 3 times 5. But this time, if I group these, I would get the same answer. But you guys use Google to explain this even more. Okay, so now let's continue. What is the identity of addition? Identity means you're getting back what you started, the number that you started with, you get it back. And if it's in terms of addition, if, for example, you have some number and you add something to it, you want to get back the thing that you started with, the number that you started with, it means this has to be a 0. That's the identity property of addition. It means some number plus 0 gives me back the number that I started with, identity. An example, if I have a 5 plus 0, well, I just get a 5 back. And closely related is the identity of multiplication. What do you multiply to a number to get the number back? So if I had like a times something and I want to get a back, right? It only happens if the unknown here is a 1. So the identity of multiplication is some number times 1. As an example, let's say I have 4 times 1. Well, that gives me the identity, gives me back the 4. Simple as that. Next question. How do you find the multiplicative inverse? Multiplicative inverse, very simple. You flip the number is how I'd phrase this. So let's say, for example, oh, we actually don't have to make our own example. We are asked, what's the multiplicative inverse of 4? So 4 as a number, we know has a denominator of 1. Currently, this 4, right? Every number, if it doesn't have a denominator, you know that it has a denominator of 1. The multiplicative inverse is flipping that number. So this would be 1 over 4. That's it. Okay, how do you find the additive inverse? So the additive inverse, you change the sign of the number. And we're being asked what the additive inverse of 4 is. So if the first number is 4, well, the additive inverse of it would be what? -4. If I have a -7, well, the additive inverse would be a 7. Just change the sign. That's all you do. Moving right along, using the graph to find, use the graph below for sections A through D. Yeah, so part A says, let me try to move this out of the way. Yep. Part A says, is this relation a function? You can tell that a relation is a function if it passes what's called the vertical line test. What that means is if I were to draw a vertical line straight down through any of these points, I can only cross any of these points once. If my vertical line hits 2 points at any given time, it's failed the vertical line test. You can only cross once to be called a function. And this one passed. None of these vertical lines that are drew are striking 2 points anywhere. Each one of them can only touch 1 point. So yes, this is a function. How to know if a relation is a function? Oh yeah, pass the vertical line test. There are other methods for checking this, but I'm going to leave that alone. So draw a mapping of this relation. So a mapping is when you have x values and you have y values, and we're going to map them together. So look, each point has x and y. So let me erase the original points that I have. The first point, let's just do this left to right. So our x values are -4. Let me zoom out a little bit so we can fit it on one page. -4, going left to right, -3. And then I have 0. There's a 2, a 3, and a 5. Those are all the x values we have. And then the y values, going from the lowest one to the highest one, the lowest y value we have is a -4. Then we have a -3. Then we have a -2, a 0. Then we have a 4. So when you're mapping these, you're going to say the point. So -4 matches up with a -2. So I'm going to draw a line from there to there. -3 matches with +4. So from there to there. This is the mapping portion. 0 goes with the -3. So 0 to -3. 2 to 0. 3 to 4. And 5 to -4. That's fully mapped. That's it. Represent this relation as a list of ordered pairs. So a list of ordered pairs, I'm going to do a brace, and each point is going to be in here, like -4, -2. That's the first point as an ordered pair. Ordered pair means you write it as an x and y. This is an ordered pair, x value, y value. Okay, and then the next one is -3, 4. Go to the next one, 0, -3. Next one is 2, 0. Next one is 3, 4. And last but not least, we've got 5, -4. And you close with a brace. Okay, moving right along. Domain deals with the x values. And the range deals with the y values. So for the domain, we just list all the x values, -4, comma, -3, comma, 0, comma, 2, comma, 3, comma, 5. And yes, I'm going to use curly braces here. And I'm going to label this domain. And for range, you're going to do the same thing. -2, 4, -3, 0, 4, -4, close the brace. Explain to yourself what domain and range means. So domain, it means where a relation has x values. And range, it means where a relation or a graph actually, so I should say relation or graph, has y values. Again, I'm going to invite you to use Google because this is an overly simplified definition. So you should use Google plus the notes that Ms. Mezzina has given you this semester to write the most robust and complete answer to that question. Okay, so just Google and notes. Okay, moving on to the next question. Ruby is selling her famous homemade cookies at a bake sale. She is selling 4 types of cookies: chocolate chip, double chocolate, birthday cake, and pistachio. The chocolate chip cookies sell for $4 each. Okay, so we should probably label these. We can say C represents the number of chocolate chip. Let's use D for the number of double chocolate. And let's use B for the number of birthday cake. Birthday cake cookies. And we'll use P for the number of pistachio cookies. Okay. So with that said, let's see if we can figure out this equation. What are we looking for? Write an algebraic expression that models her total possible earnings from the bake sale. Okay, then we'll say, I'm going to say capital E would be earnings. So to calculate the earnings, we're going to say you're selling each chocolate chip cookie for $4. So $4 per chocolate chip cookie plus $3.50 for a double chocolate cookie. And then you're selling the birthday cake for $4.25 per birthday cake cookie, and then $4.75 per pistachio. This equation here would give you the total earnings. Actually, since it says algebraic expression, I'm not going to do E equals. When you do the E equals, that makes this an equation. I guess I'm being nitpicky, but I want to be really exact. Since this is algebraic expression, we don't actually need the equal sign. I'm just going to leave it at that. Nothing wrong with what we had, but I want to really obey what the instructions are saying. Okay, so let's move right along. Question 14. Is this relation a function? So you're given this diagram, and the question is this relation a function? Remember, check to see if it passes the vertical line test. What that means is if you drew a vertical line anywhere on this graph, it can only pass, or rather strike the graph once. And it doesn't matter where I draw it, it'll only touch the graph in one location. So because of that, it's passed the vertical line test. So yes, it is a function. Why? Passes the VLT. Passes the VLT, vertical line test. I'm going to show you guys an example when it might fail. So let's say our graph looked like this. All right, let's say that's what the graph was. If I try to run the vertical line test here, boom, this is failing because the graph is touching, my vertical line is touching the graph there and there. It's failed. Vertical line test is passed only if a graph is crossed once by the vertical line. That's it. Write the range of this function. Again, folks, remember, range is dealing with the y-axis. And it basically asks you to go from what's the lowest part of the graph. So think of it as lowest to highest part of the graph. Now, are you noticing for our equation, this is the lowest part of our graph, and this is the highest part of our graph, which means we can state those y values. -5 is the lowest, +5 is the highest. So we can say between -5 and 5. And the way we do this, we use braces, or rather, sorry, brackets to enclose that. All right. Hope that makes sense. The next question is asking you to figure out the negative intervals of this equation. So negative intervals, that's asking you what part of the graph, oh, this is a thick band. Let me change that. Part of the graph that's below the x-axis. So I'm going to try to sketch that with this orange pen. I'm going to make it thicker again. So this part of the graph is below the x-axis. Also, this part of the graph is below the x-axis. So we want to say those sections that are below, and we give those sections based on the x values, where this starts here from -6 and ends at -2. So the part where the graph is negative is from -6 to -2. All right. And then there's another section where the graph is negative. So I'm going to say union, which means I have another section from 2 to 6. And you can see that over here. From right there's a 2, and right there's a 6. So you give these answers in terms of the x-axis. All right. Next question is inviting us to give, this is part D, give one increasing interval of the relation. So to determine if a relation is increasing or decreasing, I want to remind you, always read from left to right. Like, look at the graph, always look left to right. That's how you determine if a graph is increasing or decreasing. So let me see if I can use a green pen here to illustrate something. Okay, so I'm going to erase my old markings from the previous question. Notice if I walk in quotations, if air quotes, I guess, if I'm walking down this graph here, that graph is falling. So that will be decreasing because it's falling, right? Here's another section where the graph is falling as you go left to right. But on the other hand, if I start moving the graph along here, you see that it's rising. So that graph is increasing in that interval and also increasing in this interval right here. So as you read the graph left to right, as you move along the graph, look left to right. The green portions are increasing, the red portions are decreasing. Now, the question only asks us to state one of those, right? So I'm going to say, and again, everything is given in terms of the x values. So let me see if I can direct your eye. So starting at -4 and ending at where x is 0, that graph is increasing. So we can say the increasing interval is from -4, when x was a -4, up until when x was a 0. That would be the answer to that. Okay. The next question, it says, name all the extrema for this graph. What are the minimums and the maximums? So back to this diagram. Okay, let me erase the old markings again so we have a clean diagram to work with. I'm going to show you the minimums and the maximums. I'm going to use red so it stands out. This mountaintop is like a peak. That's a top. It's a mountaintop, right? So that will be a maximum. Here's another one right here, another max. Here's another max right here. So we have 3 maxes, I guess. on this graph. And then here you have a minimum. It's like the bottom of the valley. This is a minimum point. So is this. And you're going to write these out as like actual ordered pairs. So this minimum is when x is 4, y is -5. This minimum here, x is -4, y is -5. And the maximums for this maximum on the leftmost maximum here is -8, 5. The one in the middle is 0, 5. And the one on the right appears to be 8, 5. But actually, I'm having second thoughts here. You see how these two endpoints on the end have an arrow? That's not really it says that the graph is continuing. So I'm not really I don't think we should count those as maximums because it's not like a peak like this one, right? It looks like, is it coming? Yeah. So I don't think we should include these. You should check the answer key if your teacher has an answer key to this also, just to double check this work. But I don't think we should count those as maximum. So let's just do this. Let's count the actual maximum that's on there, 0, 5, and then the two minimums that we have. So the first extrema, let's do the maximum first. When we're saying that is 0, 5. And the minimums, we saw two of them. We saw -4, -5, and a 4, -5. Now, -5. Please, folks, be sure to go back and check your teacher's answers on the answer key to see if these other two I mentioned, did she mention this one and did she mention that one? Be sure to look at the answer key or even ask her. Okay. The next question is asking you to name all the x and y intercepts. This is pretty self-explanatory because you look at the graph where x-intercept means where the graph is crossing the x-axis. It could be more than one place. Y-intercept means where the graph is crossing the y-axis. So let's go back to that graph and look at the x-intercepts. Where is the graph crossing the x-axis? Right there, right there, right there, and right there. So we have 4 x-intercepts, -6, -2, 2, and 6. So for those, I'm going to say -6, -2, 2, and 6. Simple as that. Y-intercept is where the graph is crossing the y-axis, and we write that as an ordered pair, the x and y value. So let's go back to the graph, and you notice that's over here. This guy right here. So I'm going to say that's also the maximum. So whatever we had the maximum as, which was 0, 5, that's our y-intercept as well. Great. So let's move right along. The next question is, okay, go ahead and read it. So it says the sum of 3 consecutive integers is -114. What is the second number in that sequence? Okay. Remember, when you hear these kinds of questions, you got to remember that you need to set up an equation. We need 3 consecutive integers. Okay. So since we don't know what those integers are, let me just guide you on this and tell you, always call the first integer n. If they're just consecutive, you will say the next one then has to be 1 more than the previous one, right? N plus 1. And the next one would be 2 more than the original. So like that. Those are the 3 integers. This one, second integer, third integer. Now this question is asking us to figure out the second one. Okay, so we know also the keyword sum means adding. So this question is saying if you took 3 numbers that are consecutive and you added them together, that sum is going to equal -114, their sum. And at this point, we just have an equation that needs to be solved. Like terms on the left side, n plus n plus n is 3n. 1 plus 2 is 3. So the left side is simplified. Now we need to get n by itself. So we need to subtract 3 from both sides. And these are going to cancel out. 3n equals -117. So the last step is to simply divide both sides by 3, and I'm running out of space, so let me move this over here. Okay, so I'm going to just copy it down. I'm going to divide each side by 3 to get n by itself. So we end up having n equals, what's that? Negative 39? Got it. So be careful here, folks. This question was asking you to determine the second number. What we just found was the first number. To find the second number, we need to do this part, n plus 1. So we have to take the negative 39 that we got, and we're going to add 1 to it. So the answer to this, the second number of that sequence, is negative 38. Great. So let's move along to the next question. And this one, someone told me had a typo, so I changed the 136 to 138. If yours hasn't been changed yet, then you go ahead and change it on your page. Okay, let's dive in. The sum of 3 consecutive even integers. Now, this is important. A subtle but very, very important difference. The first one just said 3 consecutive. This one says 3 consecutive even integers. And that's very, very important because that means we're going to be using a slightly different equation. Oh, by the way, let me mention this while we are talking. 3 consecutive even integers. I could even change this to 3 consecutive odd. The formula or the approach would be the same for both even or odd. It doesn't matter if it says even or if it says odd. It'll be the same approach for this one, okay? So what's that approach? You call the first number n. The second number would have to be n plus 2. Again, it doesn't matter if it said even or odd. If this is odd, I would still do the plus 2. I know that sounds weird, but it is actually correct. N plus 2. And then the third one would have to be n plus 4. In other words, you're adding by 2s. One last time, just for those who are in the back and they haven't heard me. If it says 3 consecutive even, this is the equation that you use. If it says 3 consecutive odd, the same exact equation. Do not change the equation. All right. So now we are told that the sum of those 3 consecutive integers is 138. We're looking for the first one. So let's add them. N plus 2 plus n plus 4 equals 138. Just like you solved the question in the previous example, just combine your like terms. N plus n plus n, 3n plus 6, because 2 plus 4 is 6, equals 138. You're going to subtract 6 from both sides. Oh, yeah, subtract 6 from both sides. We end up having, I should have changed that to 138. I don't know why I wrote 136. This is 138. I'm sorry, guys. 138. I was so confused for a second. Yeah, so that goes away. So we have 3n equals 132. And then, of course, the last step is to divide both sides by 3. So we divide this by 3, divide that by 3. I'm running out of room again. Just going to move this over here. So n equals, I believe, 44. And this one was asking for the first number. So that's why we were just able to keep that answer and not have to do anything fancy. Just ask for the first number. Well, the first number was n right there. We have it already. That's it. Okay, here's the next question. Nick and Robert built a model rocket. They want to test how good it can fly. So Robert placed it on the ground and launched it into the sky. The rocket flies for about 20 seconds before hitting the ground. Use the grid below to roughly draw a function modeling the height of the rocket above the ground for the time it launched to the time it hit the ground. Okay, so if you're launching a rocket into the air and it's going to hit the ground, you can kind of postulate that the rocket, let's say this is the rocket here. Oh, I don't mean to draw an arrow. This rocket will be flying through the air and it's going to fly, and then eventually it'll come back down, boom, and hit the earth. This is the ground. So it's sitting on the ground. It's going to do that. So that's really what the rocket is going to do. You can, or even a baseball, anything that's flying through the air. If you hit a ball, or even shoot a basketball, it's going to take this is known as a parabolic path and come back down eventually, right? So that's all we're illustrating. To do this, I'm going to suggest that for the x-axis, let's make this time and in seconds. For the y-axis, let's call this height, the height of that rocket, Height. And this is in, is it given the unit, the height above the ground? Okay, can we just use feet? Or yeah, let's just use feet. That we don't have a unit given, so I'll just use feet. And then we have the y-axis. I'm going to say this is the y-axis. Sorry, this is the y-axis here. And this is the x-axis right there. Okay. This is 0, 0 on that grid. So we know that they're launching this from the floor, and it's going to be in the air for 20 seconds. Okay, so let's say here, let's call that 20 seconds. So this is the 20-second mark. Okay, now we know that this thing is going to be flying through the air. 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5. Somewhere halfway through the path of its flight, the flight path rather, it's going to start coming back down, boom, and hit the ground right there. That's it. You've done it. The rocket will be climbing, climbing, climbing. At some point, it's going to turn around and start coming back down. And it's going to strike the ground after 20 seconds. That's why we have the 20 here. And it would be at a certain height. I don't know how high it would go because we're not giving it any numbers, but this just wants you to sketch a roughly drawn function, and that would be it. Now it says, name the x and y intercept. This right here would be the x-intercept, where the graph crosses the x-axis. And the x-intercept is 0, 0. It kind of makes sense because if your rocket is sitting on the ground, no time has passed and it hasn't started climbing. So both the time and the height are zeros. And then the y-intercept is also 0, 0 because it's right there. The graph is crossing the y-axis at 0, 0. All right. Now, if you're thinking critically here, you would see that there's actually more than one x-intercept before he started launching and after you launched and he landed back down. So here's the second x-intercept. It's at 20, 0. What that means is it took 20 seconds for the rocket to go up on its path, and then come back down to the height of 0. So it took 20 seconds to go all the way up and then come back down to the height of 0 where you're back on the ground. So that would be your answer to that question. Okay, moving right along, here's 18. We're solving for each variable in these equations. So for this one, divide both sides by 8. Those, of course, cancel. X ends up being 20 because 160 divided by 8 is 20. Remember, you always do the inverse operation, which means do the opposite of what's being done. Next question, we need to isolate the variable. We need to isolate x. What's stopping x from being by itself? Is this negative 23? So I'm going to add 23. You always do the opposite of what's being done. Those are going to cancel. We end up with 7 equals x. The next one, we need to solve for w. W is trapped by several things. There's this 4 that's trapping it. There's this negative 3, and then there's this 3. So we need to move everything away from it. So eventually we'll have W equals some value. So that's the goal. So how do you achieve this goal? You start moving things away, and you have to do it in a very specific order. So first, you'd have to multiply both sides by 4 to get rid of this denominator. That's the biggest issue. If you times the left side by 4, well, you have to times the right side by 4, because what you do on one side of an equation, you must do the same exact thing on the other. So 3w minus 3 equals 60. Then you're going to add the 3 to both sides. So now we have 3w equals 63. And how do you get rid of the w? What's happening between the 3w? It's a multiplication sign. So the opposite, the inverse of it, rather, you just do the opposite of multiplication, which is division. Those are going to cancel out. And you're left with w equals 21 as your answer. You just repeat this process over and over again. We want to solve for e. We can't really do anything until we open up these parentheses. So our first goal would be to distribute the 8 into both of those and then distribute the 2 into both of these. We're going to end up having 8e minus 40 equals 6e minus 16. Next, you're going to subtract 6e from both sides because you want to combine your like terms, right? So the 8e and the 6e are like terms because they both have e's. They cancel on that side. Here, you're now left with 2e minus 40 equals negative 16. Now the 40 and the 16 are like terms, and then they need to be on the same side. So you're going to add 40 to both sides. Because why? You need e to be by itself. So you need to move things away from it. So those cancel. And now e is getting freer as time passes by. So what's negative 16 plus 40? If you've said 24, you are correct. And finally, you're going to divide both sides by 2. So e is by itself. E equals 12. Okay. I want to quickly remind you guys something that I thought about just now. If you're in doubt, if you're doing these correctly, there is a way to check your answers. The answer that you're finding, plug it back into your equation and do the math to see if it actually makes sense. So let's use the first one as an example. 8x equals 160. Well, we figured out that x is 20, right? So we're going to plug in the 20 in place of x and see if we actually do get the 160. Oh, 8 times 20 is in fact 160. 160 does equal 160, and that's proof that you've done the question correctly. That is how you know that you can actually score your own test, because you can test your own answers. Why don't we test the second one also, just to give you guys 2 examples of this. Again, take what your answer was and plug it into the original equation. So we are testing negative 16 equals, our x value was a 7 minus 23. 7 minus 23 is negative 16. Yes, and negative 16 really does equal negative 16. That's proof that these answers are correct. You can do that for any of these that are involving solving. Okay, so let's do the next one. Right here, it says solve for k. So we first of all combine like terms on the same side if you have any. So this becomes 8k minus 15 equals 4k plus 13. So like terms here, we have the 4k and the 8k. I'm going to subtract 4k from both sides. So what's going to happen, those are gone. We have 4k minus 15 equals 13. And now the negative 15 and the 13 are like terms. Remember, you want k to be by itself. So you want to move things away from k. So you want to move this guy away. So k is going to be free. The inverse or the opposite of that would be adding 15 because it was being subtracted. So now you want to add them. So 4k equals 28. And to get k by itself, you want to divide by 4 because 4k means 4 times k. The opposite of multiplication is division. And now your answer is finally going to be k equals 7. You know, you can test your answer by plugging that 7 back into here and here, and to see, make sure that your left side does equal the right. I know it does, so I'm not going to actually do it. Okay, so moving right along. Next question. Question F. We've got r plus 4 equals 8. When you have absolute value functions, you prepare yourself to have 2 answers, okay? And you want to split these as follows. You keep the first equation exactly as it is, r plus 4 equals 8. You just drop the pipe symbol, just drop the absolute value symbols. The second equation, you're going to copy the same exact thing, r plus 4, but change the sign of that answer. So it used to be +8, make it a -8. Now, some people prefer to make these signs the opposite and keep that one positive for the second equation. In other words, they do -r minus 4 equals +8. You can do that, but that's just so much more work. So I'm just going to do it this way because it's just quicker and easier, in my opinion. But if your teacher requires you to do it the other way around, then you do it that way. So -4 minus 4. You're going to solve each of these. I'm going to subtract 4 from both sides. R equals +4 and R equals -12. Simple as that. And that's the end of that problem. All right, so let's continue with these questions. Again, remember when you have absolute value equations, you will have two answers. You have to set up two equations, right? So we've already said that the first equation is exactly the original, just drop the absolute value symbol. So the first one will be 5t plus 7 equals 4t plus 3. The second equation that we said, you always change the sign of the answer, right? So for this one, we would have 5t plus 7 equals -4t minus 3. Yes, change both signs of the answer. Okay, so now we just are going to focus on each one individually. Let's solve the first equation. Start off by subtracting 4t from both sides. Those are going to cancel. So t plus 7 equals 3. And then, of course, you're going to subtract 7 from both sides. Sorry. And then you're going to have t equals -4 for that first answer. And we're done with that. So let's go to the next equation. For this one, you're going to subtract. Let's actually start off by adding 4t. Add 4t to both sides. Those are going to cancel out. So 9t plus 7 equals -3. Now let's subtract 7 from both sides. 9t equals -10. And to get t by itself, you're going to divide both sides by 9. And now you will have t equals -10 over 9. Yeah, it's better to leave your answers as fractions rather than make them decimal. So leave it as a fraction. Those are the two answers. 5 Tic Tacs cost 50 cents. Write a proportional equation to model buying 24 Tic Tacs with X dollars. Oh, okay. So proportional equation is really fancy words for, like, just set up a proportion. A proportion is when you have a fraction. Let's pretend it's A over B and an equal to another fraction, C over D. Of course, you would have values in here, but I'm just giving you the general idea of what that should look like. When you encounter these problems, focus on the two things that you're really relating. We have Tic Tacs and we have their cost. So I'm a huge fan of literally just writing what I'm going to put where. I'm going to decide to put Tic Tacs on the top and the cost on the bottom. But the next student might say, I don't like that. I'm going to put the cost on top and Tic Tacs on the bottom. Here's a secret sauce, which is amazing. It doesn't matter. Just be consistent. Okay, so if you want to put cost on the numerator, yeah, that's fine. And make sure you're consistent. So I'm going to keep this because I don't want to keep erasing. So the cost for 5 Tic Tacs. So I'm going to say 50 cents is the cost for 5 Tic Tacs. That's the first fraction. Equals to, I want to know the cost. So I don't know the cost. Like, how many dollars would I need to have to buy 24 Tic Tacs? That's it. And this just says set up the equation. We don't have to solve for it. That's the answer. Done. Next question. Fruit punch is being sold for 75 cents per liter. Your punch bowl can hold 3 gallons. How much will it cost to buy enough punch to fill the bowl? Oh, okay. So this is a multi-step question. We know the cost is given to us per liter, but we have the volume of this thing provided to us in gallons. So we have to change these gallons to liters to be able to calculate this. Thankfully, we can do this pretty simply. We'll start off by taking the 3 gallons, and our goal is to change these gallons to liters. So we're going to say 3 gallons times the conversion, and we're given the conversion here, thankfully. We know that 1 gallon is equivalent to 3.8 liters. You might be wondering, why did I write the gallons on the bottom? Let's see if this makes sense. If I write the gallons, one on top, one on the bottom, that allows me to just cancel out the gallons and guess the unit that's left. It's liters. That's what we wanted. So this is actually a thing. It's very prevalent in other disciplines and other other classes like chemistry. So it's a thing that you do. You take the thing that you're converting and you multiply by the conversion. Now, make sure that when you set up the conversion, you want to set it to where the things you want to cancel out, one will be on top and the other one will be on the bottom. So we have the unit that we want to be left. So now what we have here is some amount of liters, and we don't even have to multiply just yet, but we know the cost of each of those is given to us as 75 cents. So times this by 0.75. This is what we want to plug into our calculator. So I'm actually going to grab mine real quick. It's 3 times 3.8 times 0.75. And the cost for that is $8.55 to fill the bowl. So $8.55 would be your answer. Okay. Next question. How many solutions exist to the equation and why? There's several ways to explain this, but the short and sweet answer, if you ever look at your equation and you notice they're literally the same values, 4 plus 5x is the same thing as 5x plus 4. If they're exactly the same, you have infinitely many solutions. Yes, you can just write IMS. It's universally acceptable in the math world. You have infinite solutions. And this is the case because you end up having a true statement. The left side, 4 plus 5x, is indeed equals to 5x plus 4. A true statement. And any x value that you plug in here will always yield a true answer. Let's say x is 0, for example, right? If x were 0, plug in a 0 here and a 0 there. 5 times 0 is 0. 5 times 0 is 0, 0, 0. So we end up having 4 plus 0, 0 plus 4. Are those equal? Yes, because 4 equals 4. And it doesn't matter what you plug in. I could plug in ones. You get the same answer. The left side will always be the right side. So the reason here is that you always end up with a true statement. Regardless of what x you plug in, you will always have a true statement. So use your words to write that answer out. Okay. What kind of line has a slope of 0? For those of you who have worked with extensively in the past, I give you a cheat code for this. It's a kind of a strange saying, Vux Hoy. And for those who've never heard this, ask those who have. So it stands for vertical lines. This V stands for vertical lines, vertical, have an undefined slope, and their equations always begin with x equals some number. And then the other one, horizontal lines, horizontal lines have a slope of 0. This is 0. And their equations always begin with y equals whatever value, some number. So to answer this question, what kind of line has a 0 slope? Well, I guess goes in Hoy, right? So it would have to be a horizontal line. What kind of line has an undefined slope is the next question. I guess if you are following along, then you know this is a vertical line because of Vux, vertical line. Next question, find the x-intercept of this equation. Please remember this. If you're looking for the x-intercept, there's only one simple rule. Plug in a 0 into y and solve. So that's literally it. And when you write this answer, just kind of think of it this way. It's going to be some x value and the y will be a 0. So let's actually plug in a 0 here into this y. So it'll be 3x plus 8 times 0 equals -4. Well, this 8 times 0 is just a 0, so I'm going to cross that out. 3x equals -4, right? And then you need to divide both sides by 4. So the x value, I'm sorry, don't divide by 4. I apologize. Divide by 3. My apologies, because I wanted the 3's to cancel. Those 3's are gone. So we end up having x equals -4/3. So our answer for the x-intercept is -4/3, comma 0. That is it. That's the x-intercept. If you're wondering, to find the y-intercept, if you were looking for the y-intercept, because that could be potentially a question, you plug in a 0 for x, and then you find the y value. Simple. Okay. Next question, it says, show if 12 - 8 is a solution to this equation. All you do, since you're given an x and a y value, you take the x value and you plug it in. You take the y value and you plug it in, and you're going to see if the left side equals the right side. So y value is -8. We're going to plug the -8 here. So -8 equals -9/4 times x. We're plugging in the x right there, and our x value is a 12 plus 2. Then we're going to check to see if the left side is going to equal the right. So you're welcome to use your calculator here if you want. I mean, I'm not gonna. So 4 goes into 12 3 times. We have -27 plus 2. Is that going to equal -8? I think it fails. -8 equals -25. Ooh, that's false. It failed. So if it fails, the left side does not equal the right side. It's a false statement. So you're going to say it's a false statement. Therefore, this is a symbol for therefore in math, by the way. 12 - 8 is not a solution. Or you can just simply say no. Yep. Okay. Write the point slope equation for the line that goes through these points. Point slope equation, what does that look like? Y minus y1 equals mx minus x1. You have to have a number for y1 for m and for x1. So let's get to work. You got to find m first. To find m, finding slope has its own formula, y2 minus y1 over x2 minus x1. So you have points given to you, 6, 1, and 4, -3. I'm going to label these x1, y1, label these x2, y2, so I'm not going to make any silly mistakes. So my y2 is a -3, my y1 is a 1, so over my x2 is a 4, minus my x1, which is a 6. I'm going to simplify this. I'm going to have -4 over -2. So the slope for us is a 2. So we can start putting this equation together. That's going to be 2. And since we want the equation in point slope form, just choose one of the points to use. I like this one, seems like the friendly one because it doesn't have any negatives. I'm going to use that in our equation. So y minus the y value for the point I chose is a 1 equals 2x minus the x value for the equation I chose is a 6. That's it. Find the slope and then choose one of the points to plug in. Next one. Write the slope-intercept form equation of the line that passes through those points. Slope-intercept is y equals mx plus b. There are several ways you can approach this. Some people like writing this in point slope form first. I guess we could do that. Let's write it in point slope form, and then we'll convert it to this. So x1, y1, x2, y2. Point slope is what you just did literally a minute ago. So let's find slope. y2 minus y1, -6 minus 6 over x2 minus x1, -1 minus 9. So -12 over -10 simplifies this to 5 over 6. That's our slope. So in point slope form, we'll do y minus 6. I'm choosing this point to go with, equals the slope, negative 5 over 6 times. Oh, it's not negative 5 over 6. It's actually a positive, isn't it? Yeah, positive 5 over 6 times the x value, x minus x1. So we end up having y minus 6 equals 5/6 x minus, what's 5/6 times negative 9? Those of you who have a calculator, let's see, 6 goes, yes, of course you're welcome to use your calculator. I'm just distributing here. I guess it's negative 15 over 2. So now we're getting close to changing this equation to that, to y equals mx plus b. So we just need this 6 to be moved over to here, right? We have to get rid of it. So it'll be plus 6 and plus 6. Again, feel free to use your calculator for this. I'm going to move this over here. So we have y equals 5 over 6x, negative 15 over 2 plus 6. It's going to be in negative 3 over 2. I'm pretty sure. Well, let me just break out my calculator. Over 2 plus 6. Yep, negative 3 over 2. And that's the equation you're looking for. Y equals mx plus b. Okay. When you're writing equations in standard form, what does standard form look like? Ax plus by equals c. Remember 2 rules that you have to abide by. One of the rules, no fractions are allowed. Rule number 2, the x or the ax, this thing here, must be positive. It can never be a negative. Anything else can be negative, but that first thing, ax, must be positive. Now, some teachers really, really care about that. Some of them don't. But we're trying to make this look like this. See, the x and the y have to be on the same side. So add 4 over 7x to get rid of it on that right side. If you do it on that side, you have to do it here also. So these are going to cancel. We have 4 over 7x plus y equals 14 left. But remember those rules? We can't have any fractions. So how do you get rid of this silly fraction here? Good news. It's literally just multiply the entire fraction by whatever that denominator is, which is a 7. What happens is this 7, the 7 and the 7 are going to cancel out. But remember, you're distributing this into all of these. So for the first one, the 7 and the 7 will cancel out. So we're left with a 4x. The second one is 7 times y, it's a 7y. The third one is a 14 times 7, which is 98. That's the equation in standard form. Next question. We're given an equation in point slope form. We're going to write it in standard form. Once again, this is ax plus by equals c. Remember those rules, no fractions, and the ax must be positive. So let's start off by opening up the parentheses. We get 6x plus 18. We have y minus 5 on this left side. We want the y and the x to be on the same side. So I'm going to subtract 6x from both sides. Let's do that. And then those cancel. So we end up having negative 6x plus y minus 5 equals 18. Well, the constant, the number 5, negative 5, needs to be on the right side. So we're going to add the 5 to both sides. And it's gone now. So we have negative 6x plus y equals 23. So that looks good, except for the fact that ax has to be positive. We're not allowed to have a negative. And to achieve that, just literally change all of the signs to the opposite. It's really that simple. Just change all the signs to the opposite. There's a reason why that's happening, but I'll save that for another day. Just change all the signs is really the quick fix for getting rid of that negative on the ax on the first term. That's your answer. Next question. Graph a line with a slope of -2 that goes through -1, 1. So for this question, I feel like we can get away without doing too much. I'm just going to draw the y-axis right here. Y-axis, and I'm going to draw the x-axis right here. Oops. One moment. I moved the graph a little bit. All right, sorry about that little glitch. I somehow moved the graph away from where it needed to be. So anywho, so I'm going to draw back the y-axis. It's right there. Y-axis. Oh boy, why is that happening? Why? So annoying. Hang on, guys. I'm so sorry about this technical difficulty. It keeps jumping. I'm not sure why it's jumping. Oh boy, we've covered a lot of this material already. Okay, come on, come on, come on. Let's go. Let's go. Wow, covered a lot, huh? There it is. Yeah, so we want to draw the y-axis right there. And we'll draw, bro, you've got to be kidding me. Why is this happening? Come on, yo. Okay, let me try again one last time. It's a technical difficulty. Maybe let me not use that pen. I'm going to try a different pen here. Make it thicker. It's black. Y-axis. Then x-axis. That looks like it might stay finally. Y-axis, x-axis. Okay. So it's looking okay so far, I guess. We're going to survive this. Okay, good. Look, slope is -2. Now, folks, remember, slope is defined as rise over run. So if I have a slope of -2, I'm going to be rising -2. And that means go down. The negative means go down 2 and then to the right one. You never run left. And then it says it goes through the point -1, 1. So the point -1, 1 is right here. Oh, so sorry, not right there. It's actually right here. -1, 1, right there. And from that point, I use the slope to find the next point. So from that given point, -1, 1, I'm going to go down 2 places. And I'm going down because it's a -2. Down 2 places over 1. Let's maybe repeat this 2 times. Down 2 places over 1, down 2 places over 1. You want to have at least 3 points. So when you're drawing your line, it's going to be a nice, smooth curve. Let me see if I have a tool here for the curve. I do not. Okay. I wish I had a ruler, but I don't. But I'm going to try my best to join these dots. So I should have a line that looks like that. That is that equation. I mean, that's the graph of that line. Sorry, not an equation. What? All right, more graphing. Again, we need the X and Y grid. So let me bring in the X and Y grid. Here's the Y-axis. Oof, it's wobbly. Y-axis and the X-axis. Y-axis, X-axis. And then when you look at this equation, remember y equals mx plus b, the slope is 1/3 because y equals mx plus b, and the y-intercept is 4. Remember, this y-intercept is your starting point. It's where the graph crosses the y-axis. So I'll put the first dot where y equals 4 right there. And then I use the slope to guide me where to put the next point. Remember, the slope is 1/3. Rise 1, run 3. From there, I'm going to go up 1 and over 3. 1, 2, 3. Do it again. Up 1, over 3. 1, 2, 3. You can repeat that, but again, like I said, if you have 3 points, you have enough points to get you the graph that you're looking for. So there's your graph. Boop, boop. Of course, you would use a ruler. Never freehand these. All right. Graphing the next one. Remember Vux-Hoy from a few problems back? Okay. Vux-Hoy, this equation, it says x equals something. And if you remember, when we talked about Vux-Hoy, I said this: vertical lines have an undefined slope and their equations always begin with x equals some number. X equals some number is a vertical line. And it tells you exactly where the graph is going to be crossing the, if you've said x-axis, you are correct. Vertical line, the vertical lines cross the x-axis. 1, 2, 3, 4. So here's where the x is 4. So your line is going to be a vertical line going right through x, where x is 4. That's it. Oh, here's another one. This is now about y equals 1. Again, thinking back to Vox Hoy, okay? This is h equals some number. So if you're thinking horizontal line, you are correct. Let me just draw the x and y grid again. I wish the graphs came with these already drawn. Saves us, that would save us a few seconds, but it's okay. All right, so then remember Hoy, horizontal lines have a slope of 0 and their equations begin with y equals some number. Well, here's y equals some number. Where's y1? Y is 1 right here. It beats a horizontal line, so our graph looks like that. Done. Next question. One's cell phone company charges $35 a month, so that's a flat fee for phone service, and then they charge an additional 50 cents for each text message that's sent. Write the slope-intercept equation. Oh, for his total cost y per text message. Okay, so the cost is y. So y, the cost is equals to how much you're paying per text message, which is 50 cents per text message. And we'll say X. Yeah, because it said every text message, we call that X. 50 cents per text message plus the flat fee of 35 per month that you have to pay. That's your linear equation in slope-intercept form. Now, the next question is, how many text messages does one send in a month if his bill was $52? Well, if his bill was $52, that's the cost, right? So we can plug in 52 right there. So 52 equals 0.5x plus 35. And the question is asking us to solve for x. So using your algebra skills, you're going to just begin by subtracting 35 from both sides. Subtract 35 from both sides. Those cancel. And this becomes a 17, 0.5x. So you want to solve for x. So the next step here is divide by 0.5 on both sides to free up that x. And of course, on this right side, these are going to cancel. So we end up having x equals 34 text messages. So you can plug this in your calculator, of course, and do the math. This will be 34 text messages. And that's that. All right. I believe that brings us to the end of this review. Of course, there are other things that are going to be on the test that may not be on this review packet. So sometimes that happens. So be sure to not only finish this, but also ask your teacher what else you need to know. Look back over your notes. Let me see if I can stop the share for a second so we can talk a little bit. Yeah. So be sure to study diligently, folks. Okay, be thorough. This review packet is not always inclusive of everything that should be on the final. So all the quizzes that you've taken, past tests, please make sure that you look over that material. And I wish you all the best. I wish you a Merry Christmas and a very Happy New Year. I also want to say thank you for being awesome students this semester. I'll see you again soon, okay?